Pretty easy for us.
Can we go like
okay, this one should be pretty easy for us, but you got to remember what makes something a function. What makes something a function? Okay. Wait. So tell me. Do y'all remember?
Isn't it like if it's a whole number?
If you crossed out graph,
no. If it's a positive number. If it's a number.
The line does not overlap itself.
Yeah.
Okay, so y'all are thinking of the vertical line test.
Yeah.
Does that sound familiar? Okay, but there's another way to say it because it's not always on a graph. So the way that it is said normally is each input has exactly one output. Gives exactly one output. And the word exactly is the important part. Because it can give more than one output, but then it's not a function. So it has to only have one output. Okay? The way that you'll hear me normally say it is x values cannot repeat. If an x value repeats, then it's got another output, and that wouldn't make sense. Okay, so if you know that, these problems are exceptionally easy. If we look down here, we're just asking, is it a function? Is that a function? So we look at only our x values and see if they repeat. So we got 9, -4, 2, 5. Did I repeat anything?
No.
No, so is it a function? Yes. So you can see if you know what that means, then that's very, very simple. But I can't tell you, like on the test, you can't be like, I forgot what a function is, because then I'm literally giving you the answer. Okay? If we go back to the original, what it was saying is every input has exactly one output. Right? So if I had a 9, there's only 4. That is the only output that I can have. If there was another 9 with a different output, that's what would make it not a function.
Wait, can you explain that?
I'll explain it on the next one. It will make more sense. So the next one, if we look at our x values, 5, 4, 5. Did we repeat?
Yeah.
Is it a function?
No.
Okay? So what I was saying before is, on the previous slide, the other definition was every input has exactly one output. So every x has exactly one y. Okay? And the input is our x value. So if I input a 5, what I get out of that is a 3. If I input a 4, what I get out of that is a 3. And if I input a 5, we already know what a 5 gives us. So it can't give us a 4. It's got to have only one answer. Does that make sense?
Explain that more.
Our input can only have one answer. Right? So this 5 says that the answer is 3. So the answer can't be 4.
So that's why it's not a function?
That's why it's not a function.
So that's why it can't repeat.
Right. And remember, we're only talking about x. I don't care that there are 2 3's here. All we're talking about is the x part. Okay? All we're looking at is x. We don't care about y. Y has 2 3's, but that doesn't matter. Okay? Now, domain and range. Okay? Anybody remember what domain is? Which letter, x or y? Okay? X, and then that means range is y. If you tend to forget that, I just always think that I always think that we go in alphabetical order on both of those. So if I put domain and range in alphabetical order, domain's going to come first. If I put x and y in alphabetical order, x is going to come first. So you put them in alphabetical order and they'll line up with each other. Okay, so that means the domain, D, is all of my x's. Okay? 6, 18, 41, 6, and 56. Anybody think I'm doing something wrong on that? Because there is something I did wrong there.
You have to put in 2 6's.
There's 2 6's. So we don't write stuff twice. So this doesn't have to do with the function. Luke, turn around. Turn around and stop talking. Just work on your math. Or listen. Work on the math or listen. Okay? So we're not talking about functions, so it's okay that x repeated here. This is not a function. Okay? But it's okay that x repeated here. We just don't write it twice. We don't ever write anything twice. So on the range, R, we have this, and our range is 8, -9, 8, 5, and 5. And just like before, we do not repeat stuff. So we can take out one of those 5s and one of those 8s. Okay? Just to show you that that'll show up on the homework, and we've got to make sure you don't write those. Okay, so when you write down domain and range, there might be different amounts of numbers in it. Like there's 4 in this, and there's only 3 in that. That's okay. It just means there's a couple repeats. We just don't write them multiple times. Okay? The next thing is mapping. Looks just the same. I forgot to erase that X and that Y, but there you go. There it is. This first bubble is X, because X always is first. The second bubble is Y. Those are your ordered pairs. If you want to write ordered pairs from that so you can see it a little better, we can do that. Okay? So if I want to write those down, 3 is connected to 20. 3 is connected to 20 like this. 10 is connected to 12. So 10 is connected to 12. And 4 is connected to 20. So you can do it that way. If you want, or you can just learn to read it from the mapping itself. Okay, our domain is all of our x's, our range is all of our y's. Okay, so domain is just 3, 10, 4. 3, 10, and 4. That should be a bracket. And our range is 2, 12, or 20, 12, sorry. Okay, last thing, is this a function? Does every input give you exactly one output?
No. Yes.
Yes. Okay, so with functions, it's okay, again, our y's don't matter. It's our x's that matter. So all of our x's have one arrow leading. That's what we're looking for. It's okay that both of these go to 20 because that's a y value. So that is a function. You can write yes. That's why I had you rewrite it here like this. If that's easier for you to see it on, then you're absolutely allowed to do that. But remember, functions are just talking about x's. Alright, next thing, we're going to tie it into a graph. So like I said, some of you remembered vertical line test. For a function, we have a vertical line test. If you draw a vertical line, so at the bottom I'm going to write it, vertical line test. And it can't cross twice, or can't cross more than once. Okay? So if at any point on this graph I could draw a vertical line and it crosses more than once. So it's at any point. It's basically if I took a line and I moved it across, and at any point it crosses more than once, it's not a function. So I'm just going to draw a random vertical line right here. And we can see it crossed there and there. So that is not a function. Okay, this is where people have a little bit of trouble. The domain and range of this. Domain is our x values. So what we want to do is write down which x values are covered by a line. So which x values have a line above or below it?
2. Wait.
X value. That's
Sorry.
x value is this axis, right?
2 and 4. Wait.
Well, does 1 have a blue line above it?
Yes.
Okay, what about 6?
No.
There's not a blue line right here?
Yes.
Okay, what about 10?
Yes.
Okay, so everything past 0. So our domain is including 0 because we touch 0, and it goes all the way until infinity.
Oh, no.
Okay? All that's asking is, of these numbers on the x-axis, which ones have a blue line, so have a graph, above or below it. And it starts here at 0, there's one above it. And everything past 0, there's also stuff above it. Everything over here is not. That's why we started at 0.
So how do you determine whether to put a
Bracket.
bracket or a bracket?
So most of the time on these type of graphs, If it touches it, it's going to be, unless they put like literally a circle there where it's not touching that 0. So on graphs, it will be a bracket because it's going to be touching the point that you see it touch. Okay, now range. Range is vertically. So of the y's, so let's change to a different color. Of this y-axis here, which stuff has a blue line next to it? 2 does. What about 4? Does 4 have something next to it? Okay, what about 5?
Does it matter if it's negative?
Nope, does not matter as long as it's got it next to it.
Negative 1 through 5.
Negative 1. Negative 1's here.
Yeah.
It has something next to it, but what does this arrow mean?
That it's expanding.
It goes on forever, right?
Yeah.
Goes on forever and goes on forever. So it goes on forever down here.
So it's infinity.
And it goes on forever up. So it's infinity in both directions. So that's literally just infinity to infinity. So that's got a lot more concept involved rather than just reading the graph. That's why people tend to struggle with it. Okay, but this goes on forever. So even up here at like 100, this blue line will eventually get to that point. Even if it's way over here, it is still on 100 at some point. Okay, so that's what we're looking for there. And then again, the vertical line test. You just draw a line through it. Okay?
Was the range?
The range is everything. Negative infinity all the way through positive infinity, because these go on forever up and down. Okay, the last way that they will ask these questions, nope, not the last way. A similar way that they will ask these questions is just giving you an equation. So what I do with equations is I put them on a graph. Because graphs are easy to see if it's a function. Equations are harder to see that. Okay, so I'm going to put this on a graph. I don't like the way that it looks now. Y is less than negative x plus 2. Okay, so I just made it equal y equals mx plus b, so it's easier to put on the graph. Again, I would assume we know how to graph y equals mx plus b. I'm going to put a graph over here on the side and just quickly just graph that. So our starting point is at 2. That's our y-intercept. So here's 2. And then we went down 1, right 1. So go down 1 to the right 1 here. Down 1 to the right 1. This is what our graph should... Dang it, I went off the screen. This is what our graph should end up looking like. Okay, so once we have that graph, even if it's not exact, we know at least what the shape is. It's a line. So if I drew a bunch of vertical lines, would I ever cross this line more than once? No. If I drew a vertical line here, 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 I would only cross it once each time. So the first answer is down at the bottom. Yes, this is a function. Now we got to figure out the domain and the range. So which x values are covered by this? This orange line, infinity. Because it goes on forever to the left. Here, it goes on forever, and it goes on forever to the right. So there is always going to be an orange line either below or above. So that's infinity to infinity. Negative infinity. Okay, next, range. If we go on our y-axis.
Infinity.
Infinity, because it will always have something next to it. Okay? A lot of them, yes. A lot of people last year got in the habit of just writing negative infinity and infinity, because a lot of your answers will end up being, because it's going to be a linear function.
So it's a good habit?
It's not a good habit if you're just guessing the answer, but expect your answer to look like that a lot of the time. but a lot of people were getting it wrong because they would put that instead of what it actually was. So make sure you understand why that's the answer. Okay, same thing on this one, but there's something a little different on this one. Okay, what we want to think about is what about the stuff underneath here. The stuff underneath here cannot be negative, right? We can't have a square root of a negative unless we deal with imaginaries, and imaginaries can't be put on the graph. So what I'm going to do here, this makes it a little better, is 2x plus 1 cannot be less than 0, so it has to be greater than or equal to 0. Okay, because this cannot be negative, it's got to be positive. It's got to be greater than or equal to 0. If we solve that, that'll figure out our boundary for our domain. So we solve that, we subtract 1 and then divide by 2. X equals, or no, x is greater than or equal to.
Wait, don't you have to switch the thing because you divided by negative?
I divided by positive 2.
Oh.
I subtracted 1, but I divided by negative. So we did that. Okay, so this is actually our domain because we figured out what our x is, right? So we can write down our domain based off that right there. It says x is greater than or equal to. That means we're going to start at this negative 1/2, and it says x is greater than or equal to that. Okay, and then for our range, oh hey. Okay, our range is a little harder to see. We can go ahead and put this on a graph now because we know where it starts. We know that our domain starts here, and if you remember how this is shaped, Ashley Moles taught us. Remember? It's a radical, right? Okay. So this graph is going to start here at negative 1/2, and it's going to be shaped kind of like that. So now from that, we can derive what the range is. The range is our y-axis. So what y values are going to be covered by that graph?
Well, no.
From what till infinity?
Negative 1/2 to infinity.
1/2, that's an x value. What's the y value here?
Negative 0.
0. So it starts at 0 and everything above 0. Okay? Because this goes on forever. Okay? So I told you it's just a little strange. Okay? And then is that a function? Yes, because if we draw our vertical lines, it never crosses more than once. Okay, we got 2 more slides. These next 2 slides end up being pretty quick. Okay, you've done stuff like this before. It should not be super hard to do this one. Because it says, let f of x equal negative 4x plus 5. Find and simplify f of 3m minus 4. You just plug it in for that letter. So, right, we changed our x here until 3m minus 4. So let's change our x here to 3m minus 4. So equals negative 3m minus 4 plus 5. So all I did was take this and plug it into that x. Because this was an x, now it's this. So we plug it in. Now it just wants us to simplify. So distribute and combine your like terms. So that's negative 12m plus 16 plus 5. Negative 12m plus 21.
Oh my god.
Okay? This next thing says here is a subset of points, and it says find f of 8. F of 8. That used to say f of x, so it's trying to figure out when 8 is x. So we're trying to figure out when 8 is x. So 8 is x here, 8 is x here. So f of 8 is -3. Because -3 is what is next to 8 in that specific spot. We can do that same thing on a graph. If it says f of 2, remember f of 2, that was changed from f of x. Right? So when x is 2, if we look up here, what is y when x is 2? When x is 2 here, our y value is at 4. That's where that blue line is.
Wait a minute.
Okay, so what about f of 3? When x is 3, where is our line? Where is our y value? Here's 3. 6. Okay, just remember that this is your x. What you're plugging in is always your x. Your answer is your y. X is your input, y is your output. Okay? Hopefully that seemed pretty simple. Linear functions, 2.4. One thing that Luke just pointed out to me, there is something on the homework that I want to define. A constant function. Okay, what makes something a constant function is when it's just a horizontal line. Okay, so if this is our graph, a constant function would look like this. Just a horizontal line, because it is constantly giving the same y value. It is constantly giving the same output. Okay? Every x value gives the same y value, but we don't care if the y value is repeated. So that's okay, but that's a constant function. Okay, next, linear functions. Y equals mx plus b. You might see it not written as y equals mx plus b, but we know that. Remember that this is the exact same as y. So y equals mx plus b is the same as y equals ax plus b. Okay, a couple things to remember about this. The m, or the a, is our slope, and we would like our slope in a fraction if possible. And our b is our y-intercept. And our y-intercept, a lot of times they like it to be in the form of a point, actually. So 0, comma, b.
Why B? Oh, B, okay.
Yeah, because we use that number.
Yeah.
Okay, so that's just a reminder. So a couple lines we're just going to throw onto the graph. B is our starting point, so I'm going to use red on this. That's why I put that red dot there. So we're going to start here at -3. So at -3. And then we're going to go up 1, right 4. And I always go to the right. I always go to the right. So we either go up and down based on if it's a negative. But we always go to the right side. So up 1 over 4. And then up 1 over 4. And there is our point. Okay. Next one. Remember that f of x or that g of x. That f of x or that g of x is the same as y. So that's the same as y equals -8. Okay. Y equals -8. And I mentioned this last class. If it's ever just a letter equals a number, what I always say is axis and then at. We're going to go through the axis, the y-axis, at -8. Okay, so I'm going to find -8, and I'm going to go through that axis at a perpendicular line like this. Yes. Okay? So that's axis, at, and that's whenever a letter equals a number. Doesn't matter which letter, as long as you know which axis is which axis. So same thing down at the bottom here for the blue. That's axis. So the x-axis at -1. So go on the x-axis at -1, put a dot there, and then draw a perpendicular line to that point.
So do you always have some of those arrows there?
The arrows.
Like on the end of it?
Technically, the arrows are what turn it into a line rather than a line segment. So yes, but remember you're doing it on my math app.
But if you did it on like your text.
I'm not going to count you wrong if you've got the points correct. Obviously, I'd like you to draw the arrows, but on the first one, I didn't draw the arrows. So,
Okay.
if you do the math right, I'm going to give it to you. Okay, slope formula. Slope formula is going to be just like the distance formula, meaning I'm going to give it to you maybe on a quiz, but on the test, you're going to need to know it. Okay? Slope is rise over run, right? So just remember rise over run. Okay?
Oh, that was fun.
I always spell rise wrong, so you know that the Y's go on the top. Okay? Rise over run. So Y2, just like on the distance formula, let's label them. So this is X, Y, X2, Y2. So 7 minus -2 and 6 minus -5. I'd be very careful on this. Most people make the mistakes because the formula itself involves minuses, just like this one. So there's a lot of times where they cancel out like they just did. So that's going to be 9 over 11, and we would simplify that if we could. Okay, on the bottom one, y2 minus y1. y2 is 1 minus y1 is 5 over x2 minus x1. So that's -4 over -4, which simplifies just to the slope of 1. Okay, again, you have done that multiple times. Just make sure to have it memorized. You haven't seen it probably in a while. Alright, positive slope, negative slope, no slope, and zero slope. The two that people get confused are these last two. Positive slope is when the line goes up. Negative slope is when the line goes down. Okay? What I mean by up and down is if you read it on a page. If you read from left to right. So if it goes up from left to right, it's positive. If you read it from left to right and it goes down, it's negative. Okay, but the ones people mix up is this no slope and this zero slope. Okay, no slope is the same thing as undefined. Right? Undefined. And I know I spelled this wrong. I'll explain it. Okay? The easiest way I've said to remember this is look at the first letter. Right? The first letter in no slope. No slope. The first letter shows you what that line should look like. It's a vertical line right there. Okay? Zero. The first letter tells you it's going to be this horizontal line. Okay, so I just look at the first letter, and that reminds me. The other way that I tell kids to remember it is something that I watch in my algebra classes called Slope Dude. Have you all ever seen that?
Yeah, we saw Slope Dude.
You saw it in geometry?
Yeah.
Okay. So what I decided to do instead, when he falls off that cliff and yells, and it says something like, he yells the worst word in all of math, undefined. I just say that he falls off and he's undefined and he dies. So you can remember it that way too. He falls off the cliff and he dies. So undefined. That's it. Just like I misspell rise, I misspell undefined on purpose. Okay. Last slide.
Hey.
Graph the line with the given point and the given slope. Okay? So we have a point and we have a slope. We could do point slope form and change it to y equals mx plus b, which we'll talk about next class, but we don't have to do that. We're given this point, let's put this point on the graph. At 1, -1. So go over 1, go down to -1. And then from that point we can just use our rise over a rise over run. That slope. So go up 5, 1, 2, 3, 4, 5, and go over 4, 1, 2, 3, 4. And there are your 2 points, so then we can create our line based off of that. And there's our point. Okay, next class we will talk about point-slope form. Do y'all remember point-slope form? Or do you at least recognize what it is? Point-slope form is exactly the slope formula. You just multiply both sides by this x minus 2. So that's why it's x2 minus x1 in y2 minus y1. So it's the same formula. You're just moving something a little bit. Okay, that's the end. Any slide you need me to go back to?
No.
Okay, I would hope today seemed just like review. I just had to get it back in your head.